Let's uncover the phenomenon known as sensitization of austenitic stainless steel. In this session, we will explore the concept of sensitization and its impact on the corrosion resistance of stainless steel. Sensitization in austenitic stainless steel refers to a phenomenon that makes the material susceptible to corrosion, and hence can have profound implications on the performance and integrity of metals when exposed to elevated temperatures during manufacturing, welding, or high-temperature service. Austenitic stainless steel contains key elements such as chromium and nickel, which contribute to its corrosion resistance properties. When exposed to oxygen, the chromium in the steel reacts to form a passive oxide layer on the surface. This layer, primarily composed of chromium oxide, acts as a protective barrier against corrosion. Sensitization occurs when austenitic stainless steel is exposed to certain temperatures, typically ranging from 370 degrees to 815 degrees. During this exposure, chromium carbides can form at the grain boundaries. The precipitation of chromium carbides at grain boundaries leads to a depletion of chromium in the surrounding areas. The reduced chromium content compromises the material's ability to form the protective passive oxide layer, making it susceptible to corrosion.